Yes, hello everyone, welcome back to our channel students. In our previous video, we have talked about group 17 elements. So, in this video, we are going to talk about very important element of group 17, that is chlorine. Chlorine, it is represented by Cl. I have said you that group 17 elements will be available in combined state. Clear why it is so? It is not available in free state, but it will be available in combined state. It is because of their electronic configuration, which is NS2np5. It says that there are 7 valence electrons in its outermost orbit. So it requires only 1 electron to obtain the stable octet configuration. So these group 17 elements will be always ready to gain 1 electron to achieve the stable octet configuration. So this chlorine is available in the form of Cl2. Clear? So it is in the combined state. Cl2, it's a gas actually. So it is a greenish yellow gas. Greenish yellow. Chlorine, it stands for greenish yellow itself. Greenish yellow, and it is having the pungent smell. Yeah, and it is quite heavier than air. Actually, it is 2 to 5 times heavier than air. Yeah. So now let us look at the preparation, laboratory preparation of chlorine. How can we prepare chlorine? Preparation, we prepare chlorine by using potassium permanganate, that is KMnO4. When you treat this potassium permanganate with hydrochloric acid, you will get KCl, potassium chloride, KCl, MnCl2, manganese chloride, and water, and with the liberation of our chlorine gas. Clear? So this is the reaction involved, very important reaction which is involved in the preparation of laboratory preparation of chlorine. We will treat potassium permanganate with HCl, hydrochloric acid. We get KCl, MnCl2, water, and Cl2 will be liberated. That is our chlorine gas. Clear? So this is not a balanced equation. Let us balance it. So 10, 2, 8, and 5, if I am not wrong. Yeah, it is 5. Clear? So if you are free at your homes, you can balance these chemical reactions. This is a simple method of preparation of chlorine. Now let us look at the properties. Properties means how do these chlorine react with metals? How do this chlorine react with non-metals? And what is the affinity towards hydrogen? Okay? This chlorine reacts with metals. Reaction with metals. Clear? So let's take an example of aluminium. Aluminium is a metal. If this aluminium is treated with chlorine gas, it produces aluminium chloride. This is not balanced. We have 3 chlorine, we have 2 chlorine, so 3, 2 now, yes, 6 chlorine, this balanced aluminium is 2. Clear? So when you treat chlorine with metal like aluminum, it forms aluminium chloride. Respective metallic chlorides will be formed. When you treat chlorine with non-metals, reaction with non-metals. Let's take the example of sulfur. S8. When it is treated with chlorine, it forms S2Cl2. Clear? So this is also not balanced. We have S8 here, it is huge. So yeah. So it is S2Cl2. Sulfur is balanced. Chlorine, we have 8 is 4. So it is bad. Clear? So when chlorine is treated with nonmetals like sulfur, it forms respective non-metallic fluorides. Clear? So this is the reaction regarding metals and nonmetals. Now let us talk about the affinity with hydrogen. Clear? When chlorine reacts with, it forms hydrochloric acid. When chlorine reacts with hydrogen, it forms hydrochloric acid. When again the same chlorine reacts with H2S gas, it forms 2HCl, same hydrochloric acid, with the liberation of sulfur. So it means that it has great affinity towards hydrogen. It readily reacts with chlorine, readily reacts with hydrogen to form hydrochloric acid, and with this chlorine readily reacts with H2S gas to form hydrochloric acid with the liberation of sulfur. So students, now let us look at the chemical properties of chlorine. Chemical properties means how do these chlorine reacts with other elements and what are the different products that we get when we treat this chlorine with other elements. Clear? So now let us look at the reaction with ammonia. NH3. In the first reaction, let's take ammonia in excess. We have excess ammonia. When you keep this excess ammonia with chlorine, we have ammonium chloride with the liberation of nitrogen gas. Clear? So this is one thing, it is not balanced. Okay? And the second thing is when you treat ammonia with chlorine in excess, you treat ammonia with chlorine gas as excess, you get a compound. Nitrogen dichloride is an explosive compound. Nitrogen dichloride with sodium chloride. Sorry. Just a second. Yes, it is HCl. It's not balanced. Let us balance it now. 6, 8, 3, 6. It is because we have taken ammonia in excess quantity, and whereas in the second one we have taken chlorine in excess quantity. So this is the balanced equation. You need to try balancing in your homes. Clear? So you can observe this. The reactants are same. In both the reactions, we have ammonia and chlorine itself. Clear? But whereas the products are different. In the first case, we have ammonium chloride. Whereas in the second case, we have nitrogen trichloride. What makes this product different? It is the quantity. It is the amount of the reactants that we are using. In the first reaction, we have ammonia in excess quantity, 8NH3. Clear? We have 3Cl2, we have got ammonium chloride. Whereas in the second case, we have NH3, we have 3Cl2. Clear? We have chlorine in excess. So it gives nitrogen trichloride with the liberation of hydrochloric acid. So this is the reaction, first reaction. And next, what will happen when it is treated with sodium hydroxide, concentrated and dilute sodium hydroxide? Reaction with sodium hydroxide. Now, first of all, let us treat with cold cold and dilute sodium hydroxide in the first case. So it forms sodium hydroxide when it is treated with chlorine. When it is treated with chlorine, it forms sodium chloride, a salt, and sodium hypochlorite with the liberation of water. Clear? So when cold and dilute sodium hydroxide reacts with chlorine gas, it forms sodium chloride and sodium hypochlorite it is. Sodium hypochlorite. Clear? Hypochlorite with the liberation of water. This is not balanced. Let's balance it. Only it's required. We have problem only with sodium. Clear? This is the reaction with cold and dilute sodium hydroxide. What happens? What happens when the same chlorine is treated with hot and concentrated sodium hydroxide? With hot and concentrated sodium hydroxide. In this case, we have sodium hydroxide, chlorine. We will be having sodium chloride itself, but this product will be having NaOCl thrice. Clear? And the liberation of water. This is not balanced. Let's balance it again. So 3, 5, 3. This is sodium chlorate. Sodium chloride. See here also the same thing. We have the two same reactants. Observe, in both the reactions we have sodium hydroxide and chlorine gets in. The products are different. We have, in the first case we have sodium hypochlorite, whereas in the second case we have sodium chloride, OCl thrice. Clear? Why it is so? Because of the presence of dilute sodium hydroxide in the first case, whereas in this case this is concentrated and hot sodium hydroxide. See students, so not only the reactants, but also the reacting conditions also very important in getting the desired product. Clear? So these are the two reactants in which we can show that there are different products where even though the reactants are same, which decides on the conditions of the situation of the reaction. Clear? So now let's see how it will react with slate-like calcium hydroxide. Reaction with slate-like, that is CaOH twice. So when you treat chlorine with calcium hydroxide, that is slate-like, generally known as, you get calcium chloride and calcium Cl3 thrice, that is your bleaching powder and byproduct as water. This is not balanced. This is bleaching powder. What you use in your daily life. Let's balance it now. So students, so this is the reaction in order to obtain the bleaching powder. This is one of the main important use of chlorine in the preparation of bleaching powder. Bleaching powder is very used in our daily life. Now let us look at the uses of this chlorine. Yes, students, now let us look at the uses of this chlorine. Uses of chlorine. What is the primary use of this one? This chlorine, it is used as a powerful bleaching agent. Used as a bleaching agent. Here it is because when you treat this chlorine with water, it forms hydrochloric acid with the liberation of this nascent oxygen. I have said you that we have discussed regarding this nascent oxygen when we are talking about ozone in our previous video. This monoatomic oxygen, we call it as nascent oxygen. Yeah. So what is the use of this nascent oxygen? What is the role of this nascent oxygen which is acting as a bleaching agent? Yeah. So when you treat colored substance, colored cloth maybe, with nascent oxygen, it makes this cloth or it makes this colored substance colorless. Yeah, this is the property of bleaching agent. So chlorine plays a major role. Yeah, when you treat chlorine with water, forms hydrochloric acid with the formation of nascent oxygen. This nascent oxygen is responsible for making the colored substance to colorless. Clear? So this is the primary use of chlorine, and the second one is used in the preparation of dyes, detergents, those type of products, etc. Here, this is the second use. It is used in the preparation of dyes and detergents, and it's also used in the extraction of gold and platinum. The noble metals like gold and platinum can be extracted by the usage of this chlorine gas. And the fourth use of chlorine is it is used in sterilizing the water. Sterilize water. It is used to sterilize water. Okay. So these are the four simple uses of chlorine. One has the primary important use. It is used as a bleaching agent. Clear? And the second one is it's used in the preparation of dyes and detergents, and then it is also used in extraction of gold and platinum noble metals, and last one is it is also used in sterilizing the water. So this is regarding chlorine. Thank you.